Hey, South Carolina's Math and History, and we are going to learn about the derivatives. So, when you hear the word derivatives, and you love learning about math, you probably know this or heard about this in a field called calculus. And it is something that is learned in a calculus field. Normally, this would be learned in 11th grade to freshmen in college. But derivatives is one of the easiest things to learn and one of the first things you might want to learn about. What we're going to do is we're going to make this lesson very easy to identify, but have the exact same idea of learning what it is. In fact, since we're making it a bit simpler, derivatives is all about taking things down a notch, because when you find a derivative to an equation, you are always going to try to find what it is by taking the power down a notch. So, in order to do that, there are two ways we can find the derivative of an equation. There is one, we can call it the chain rule. That is a strategy. Or two, we can call it the power rule. The chain rule is more complex and it's a lot harder to strategize. But the power rule is a new way of thinking it. If you do it either way, it will still give you the same answer. So let's do it. Are we going to do it the easy way or the hard way?
Look, everybody, we can do this the easy way, or we can do it. No, run! They took the hard way. Fire! Fire!
Vitruvius, which way to Crab Cuckoo Land?
Head for the big bright thing in the sky.
We are going to use the power rule because it's the easy way to understand. Using the chain rule is a lot more complex and it would take a long time to understand because there are much more steps to this one. They will still give you the same answer. So, when you try to find a derivative to an equation, we have to take that thing down a bit or level it down. So, there's a formula that we're going to look at that will help us take it down a bit. The formula is, you've probably seen the term d over dx. That is saying you are trying to find the derivative of the variable x. Well, we have a variable x right there. And other times, you could find d over dy. Instead, that y is saying, find the derivative of y. But we're not going to do y because we don't have a y in our problem. That is why we use the letter x. So when you try to find the derivative of the x variable, you are going to have a variable with an exponent. But to find the derivative, you have to move that exponent in front of the variable and decrease the level of that exponent by 1 once per term. We get to use that formula and level this down a bit. Let's use the example. So we have f of x equals x to the power of 8. We're going to move that 8 down here, and we're going to put it right here as 8. But we have to power the exponent down by 1 level. So we have to do 8x to the 7th power instead. So right here is the derivative of x to the power of 8. What we just did is plug it in easily into the formula. Let's see another example. If we do f to the function of x, but we have 3x to the 6th power. We already have a coefficient there, but we can still downgrade the entire problem. We can move that 6 and that 3 down here under the problem. So we have 3 times 6 times x. And we got to take that 6 down and power it down. So now we have 3 times 6 times x to the power of 5. When we simplify that, our new derivative will become 18 x to the power of 5. So, working on derivatives or finding it from a function is actually more simpler than you think. Hang on, this reminds me of something. If you ever play Yu-Gi-Oh! And you probably heard about what a spell card is, then the derivative formula reminds me of this spell card. It's called Cost Down. Discard one card until the end of the phase. Reduce the levels of all monsters in your hand by 2, even if they are summoned. That reminds me that we had to put that 8 down here. That could act like discarding your card to your end phase. Then power that level down a bit is the second part of the card. That is useful when your monster's powers and your levels are too high. And that can be an example of a derivative. In a nutshell, the last thing we can do is we can solve and find the derivatives if we have more than one object on the field. Here's an example. We can take this thing down and this down, and we have 4 times 5 times x to the power of 3. Level this down. Then we can add that by 6 and 3 go down here. 3 times 6 times x to the power of 5. Level this 6 down a bit. So now we get to simplify with 2 terms on the field. 4 times 5 is 20, x cubed. And we have to add that by 3 times 6 is 18, x to the power of 5. So when finding a derivative, you don't have to have just one object on the field. You can have 2 objects on the field. And that is how we can find the derivatives. Before this video ends, the question is, why do we use this in calculus? And why do we do this in real life? Well, if you ever ran in a race before, or if you ever watched the stock market, you can realize that when you try to have a constant slope on a graph, it's impossible because it's literally always changing. Derivatives measure if that change of rate or how the speed of that thingy changing in the stock market or the car's speed is going to go up or going to go down. So derivatives really help in the financial world. Here's an example. We are going to look at Amazon. So remember, derivatives in the real world measure how fast something is constantly changing. And that concludes the video. Thank you for watching Top Penalized Math Industry. Like and subscribe.